In this video, we'll be talking about research methods and ethics in information technology. Research is a systematic inquiry that investigates hypotheses, suggests new interpretations of data or texts, and poses new questions for future research to explore. When you conduct research, you follow a deliberate process, reviewing existing information by digging into various sources and end up with a result that should inform new or improved existing process, products, or even add to literature in that chosen field. Overall, research employs a valid and proven process and principles to create knowledge. Research gives us an opportunity to test things. Without research, it is practically impossible to enhance or create new knowledge. Knowledge makes the world go round. Every day we literally make decisions and solve problems. Some of these decisions are easy, while others require intelligence gathering, reviewing a number of options before us, and then making an informed decision based on these options. At the end of this decision making, we have the opportunity to implement our choices, evaluate and measure the results. The results could serve an interesting avenue for future research. Your research will often dictate the kinds of research methodologies that you use and the methods that you will use to collect your data. Now, what's the difference between qualitative and quantitative research? The purpose of qualitative research is to provide insights into the setting of a problem, generating ideas and/or hypotheses, perhaps for later quantitative research. It's usually based on a small number of non-representative cases, and the data collection approach is unstructured or semi-structured. The data analysis is non-statistical and the outcome is exploratory and/or investigative. Quantitative research, on the other hand, is used to quantify data and generalize the results from a sample to the population of interest. It usually involves a large number of cases representing the population of interest and may be followed by qualitative research. It uses structured techniques such as surveys for data collection, and the analysis is usually statistical, and the outcome may be used to recommend a final course of action. You will be introduced to a case study that involves researching and designing new ways to improve an IT system. You will be required to research existing data and information, including opinions on the subject. Your task will now involve coming up with enhanced or new ways to solve this problem. You'll be exposed to different ways of collecting data based on qualitative and quantitative methodologies. As you conduct your research, be mindful of ethical issues. Research involves a balance between protecting research participants and upholding human rights, as well as gaining knowledge to find answers to solutions. Try not to violate basic standards involving honesty, fraud, and plagiarism. We'll be discussing the significance of literature reviews and references. From experience, many students pull information or literature on previous research done in an area and forget to cite the sources. In some cases, they're totally unaware that citing sources is very important in research. Failure to cite is considered academic dishonesty. I want you all to pause for a minute and look at my citation on the definition of literature review on this slide. Note that I've referenced this website source in APA format. I am sure you will have been exposed to different ways to cite sources in APA, MLA, Chicago, or Turabian formats. The website above is useful for citing appropriately. With the exception of exploratory research, you will find that you're planning to work on something that's been done already in some shape or another. Conducting a literature review provides guidance not only on what's been done in the field, but what methods were utilized. Narrowing your data sources to reputable publications, such as highly rated peer-reviewed journals, can help shape the direction of your research and ultimately the outcomes. APA, the American Psychology Association, has a style that is most commonly used to cite sources within the social sciences. MLA, Modern Language Association style, is most commonly used to write papers and cite sources within the liberal arts and humanities. The Chicago Manual of Style, CMS, covers a variety of topics, from manuscript preparation and publication to grammar, usage, and documentation, and has been lovingly called the editor's Bible. Literature review and references, specifically looking at electronic health records. This is actually one of the topics that you'll be working on throughout this course. So your literature review really is going to cover a lot of the things that you'll be working on with respect to electronic health records. You will be involved in analyzing and designing a new information technology application known as the EHR. And throughout the course, you will see me refer to EHR most of the time. Really, it's about electronic health records. So you'll be required to conduct a thorough review of literature on what an EHR really is. Also, you're expected to look at the components of an EHR and specifically look at the workflow and the architecture of an EHR. Mind you that you will be collecting important information that will be relevant in the design of this EHR and really focusing on those three key areas that we talked about. You would need to do a thorough review of literature, look at case studies, and even some of the interviews that have been conducted, and I think they're presented in this course using some of the videos that you will be looking at. Besides the literature review, you'll be expected to look at a case study on a hospital. This hospital is known as the Franklin Regional Hospital. This is a fictitious hospital that's been designed specifically as a case study throughout this course. You'll be looking at the challenges and opportunities with implementing EHR at this hospital, and also you'll gain background information on the strategy, the goals, and the assumptions of EHR at the Franklin Regional Hospital, which is the fictitious case study you'll be looking at throughout this course. So what really is an EHR? It is a digital version of a patient's chart. EHRs are real-time patient-centered records, and they make information available instantly and securely to authorized users. And those users might include patients, might include doctors at the hospital, nurses, and pretty much every health record worker in that organization, every health worker that has to review those records to be able to make informed decisions and offer the service that patients most deserve. So, while an EHR does contain the medical and treatment histories of patients, it actually is built to go beyond standard clinical data. It goes beyond that to include administrative and financial data and every piece of data that's collected in the provider's office, and that's usually inclusive of patient care in any continuity of patient care environment. We'll be looking at systems planning. We'll be looking at your role in planning a new system. In this case, that will be the electronic health record system that you're developing for Franklin Regional Hospital. What's your role in the whole process, and what are some of the things that are involved in really planning and strategizing for this new EHR? So what's your role in the development of this new system? It starts with careful planning. And planning really requires an understanding of some of the components of this new system. And these components are going to touch on people, process, technology, and governance issues. So as part of your systems planning, you will be looking at the problem that this particular EHR system poses to the organization. You will study the problems and needs of the organization, in this case, the Franklin Regional Hospital, and you will determine the best approach to improve the organization through the use of this combination of people, methods, and information technology. Your role also involves helping the system users and the managers to define their requirements for this new system or for the enhancement of this existing system, if that's the case. You want to help them justify the need for this new or enhanced system. Oftentimes, automation is something that many organizations battle with, but you have to understand the reason behind it. What's the need for that organization, and why should they put their money or their effort into developing this new system? Part of the process of building this new system is really planning and justifying the need for this automation. There are usually two main activities that are involved in the planning of this new system. You have to identify the need. Remember the EHR project in this case? why do we need this new system? That's the first question you want to answer. You have to investigate and determine the scope of this system. Now, an EHR system is very broad and covers a lot of issues from administrative, financial to clinical issues. But in your case for this course, your scope will be limited to the component that you're going to narrow your EHR to work throughout this course. So the components of the EHR means that there's a lot to cover in terms of design. We'll look at system strategy. We're going to be looking at some of the key questions that organizations need to ask and also speak to their users about in designing their new EHR system, which is the example that we've actually chosen throughout this course. So system strategy is related to systems planning. In fact, systems planning is a part of a bigger system strategy. In other words, your planning is actually a subset of your strategic direction that you're going to take your EHR through. Some of the key questions to ask here include, why is this system being developed? In this case, why are we developing a new EHR system? Some key questions to also ask include, who are going to be the users of this system? If there's an existing system already, the current system and the future users, you want to determine who these users are going to be. Is this system going to be a new system that you're going to build from scratch? Or is it going to be an upgrade or an enhancement or extension to an existing system? Answers to some of these questions are going to really impact the success of your new EHR. Other questions really include which functional areas or departments will be using the system. Oftentimes, the users of the system are going to determine the success because it's going to come back to adoption. If all these users are not involved in the whole process, then it is difficult to claim collective ownership. And the more people are involved in this system, the better the success at the end of the day. So your research should be able to answer all the key questions from some of the previous slides. Make sure you understand what the users want. For example, why do we need the system? You need the right answer to that. Who are going to be the users of the system? When is the system being deployed and when do we expect it to be fully functional? And what are the key requirements of this new system? Because part of your process is building a technical requirements document that's going to answer a lot of these questions. And your research should also examine other things like what are the strategic goals of the organization and how do these goals actually mesh with the goal of this new system? How does the proposed system actually support the bigger organizational goals? What factors are critical to the success of this proposed system? And how would you know that you've actually built the right system? So what criteria are you going to put together to be able to evaluate the proposed system's performance? Because at the end of the day, you want a system that's not only efficient, but also effective in addressing the needs of the organization. We're going to look at a well-known methodology known as a Systems Development Life Cycle, otherwise the SDLC. The SDLC is a functional approach that's been followed for decades in the design of new systems. So in this segment, we will be looking at the different steps that the SDLC actually covers in the design of new systems. So the SDLC is really a methodology. A methodology is a proven process that's been utilized over the years to help developers and designers of new systems ensure that they cover all the key areas that are required in the design of a new system. The methodology allows you to follow a step-by-step set of procedures that allows you to make sure that every single component of your new EHR, in this case, is actually well covered. So, again, it's a series of defined phases, and they're usually performed in sequence. And the sequence allows you to have a framework that you can use in helping you complete your project. The SDLC is actually an approach that's evolved over the years. It came out as a hard systems approach, but over time has become a mix of a soft system and a hard systems approach, all aimed at ensuring that users, the eventual users of a system, are involved in the development or the design of a new system. The phase of every output becomes the input for the next phase. The phases all complete a cycle that is extremely iterative. At the end of the day, the key factor is to ensure that there's a real partnership between the designers and the eventual users of the system. So the initial planning and strategy, to a large extent, the research that you've been working on, will become part of the SDLC methodology. You would remember from the previous weeks what you've worked on that you've actually done a lot of research, looking at the different areas of your EHR component. Now, all of these become part and parcel of the planning and the strategy that goes into the different phases of your SDLC. In fact, the very initial phase of your SDLC covers your planning and your strategy. And again, because the result of each phase becomes the input to the next phase, you have a well-rounded methodology that allows you to build a solid or design a solid system. So this is what a typical SDLC methodology looks like. It starts with your planning at the very top. And you would notice that between your planning and the end result, which is the maintenance, there's a lot of testing that goes on throughout the process. After your initial planning, which is your first phase, you move to the next phase where you begin to identify the potential issues that you're going to need to address with this new EHR system. So part of that involves conducting an analysis of the proposed system, doing a feasibility study of all the different areas that the system will actually address. And this will include economic, technical, operational, all the way to legal issues in the design of this new system. Oftentimes, at the end of this process, you have to be able to put all the requirements together and have some sort of a prototype design created before you move on to implement your new system. And one really good thing with the methodology is that you conducting your feasibility isn't something that is restricted to only one phase. It is something that touches on multiple phases, and at the end of the day, the system that you design constantly goes through a process of continuous improvement, because you will always maintain that system. And anytime you find out issues that are not relevant, you can go back to the drawing board and start the whole process all over again. So this methodology is a proven process that's been used over the years and still being used today in the design of new systems. That you build will require some sort of data to be inputted into the system, go through some processing, and obviously give you information. So in this segment, we're going to focus on systems analysis with emphasis on data requirements. Now, your role as a systems designer oftentimes might merge with your role as a systems analyst. But oftentimes, when you look at data requirements, what you're doing is really understanding the data as part of your overall planning and strategy. In some cases, you function both as a systems designer and also as a systems analyst. If you recall this methodology, we looked at this initially in some of the other segments, sort of looking at the different phases that you go through in your systems development lifecycle methodology. So you can see that data analysis and part of your requirements is included in phase 2 of this SDLC methodology. Now, systems analysis is part of your requirements gathering, and it is a fundamental part of the research that you conduct when you begin to pull requirements together to build a new system. There are two common approaches that you follow in the analysis and design of systems. The first one is a structured systems analysis and design approach, and the other one is an object-oriented approach. In the SSAD approach, you're essentially following a number of steps that are very similar to the SDLC to help you not only understand and analyze your system, but allow you to remember all the critical elements that you need when you're developing your new system. The object-oriented approach emphasizes your ability to reuse some of the components of your design. These two approaches involve the use of UML. That's your Unified Modeling Language. That's the language that allows you to create something that is consistent, that the eventual developer of the application is able to use and translate into something that becomes workable, which becomes your eventual program. Now, the models that you create during the analysis phase become an integral part of the overall design specifications. Again, we did talk about this at some point. These are the different tools that you can use to be able to help you capture all the requirements for you to build your eventual system. So we talked about the data flow diagram, your DFD, your flow chart, your content diagram, and obviously your conceptual data model that allows you to capture not only the high level of your data model, but also go deeper into some of the other intricacies, looking at the cardinalities and relationships between your different data functionalities. Focus on workflows as part of your systems analysis. So unlike looking at data requirements only, the workflow captures the entire IPO process that we talked about at some point. IPO being input, processing, and outputs. So your workflow allows you to present all of the key requirements that your new software will be based on. Most of the time, your input will be the data that it actually pulls from the outside environment. The processing is what it does in the conversion of the data into something else that becomes really meaningful that the system could use to make decisions and solve problems. And what exactly is that thing? That's your output. In other words, your information. So every good system should be able to have a process that allows it to very quickly convert data into information. And that information becomes a key part of the decision-making process and also the process that allows you to solve problems and get the organization going. So the software inputs the data, which often becomes processed into information. And understanding those data elements and the mapping that takes place through your UML becomes a key integral part of your systems analysis. Again, this is a very descriptive flow diagram that shows the capturing of data in an inventory management system. And you can see the relationship from high level to some of the descriptions between the different processes. So what is happening at every stage is being presented in this diagram. So it's a little bit more detailed than having a simple data flow diagram. It goes beyond that, but also captures some of the concepts and the context as well in the relationship between the different entities and attributes. So, if you recall again, we did talk about this, your DFD, your flowchart, your content diagram, or your conceptual data model. These are all the different tools that we use in capturing the input, the processing, and the output of data between the systems that we're developing. Previously, we talked about conceptual modeling being one of the tools that we use in system design. Now, in this segment, we will focus on systems analysis, paying particular attention to that conceptual model that we previously mentioned. The data flow diagram that is captured usually covers not only data requirements, but also the process flows. However, most of the time, we fail to capture the detailed relationship between the different data elements that are flowing throughout the system. And this includes the data elements that are coming in from the input that have been processed and being released as outputs. The conceptual data model will eventually be translated into a physical design. Now, the conceptual data model actually captures the relationships or the key attributes between the different components of your system. And one of the key deliverables at this point is your entity relationship diagram, otherwise known as ERD. The ERD captures the different entities involved in your design and the relationship between those entities. Mind you, an entity is anything that you can describe in the design of your new system. And attributes are characteristics of entities. Those are things that we use to actually describe those entities. The conceptual data model shows the relationship between the data flows from one entity to another. And oftentimes you can actually capture this using freely available tools like your Microsoft Visio. This oftentimes comes as part of your Microsoft Office package. So here is a simple example of a conceptual data model. You can see that you not only see the entities, which will be, in this case, your supplies, your shipment, your items, production plan, product, and the master schedule. You also see some of the attributes that have been used to relate the different entities. You can see what happens between the entities and how they actually interact with each other. Here again is another sample conceptual model that actually shows you again the relationship between the different entities. And you can see how the entities actually speak, in other words, interact with one another. Strategy and analysis in the design of your new system. Oftentimes, you have to pay particular attention to looking at some of the logical requirements in that system. So in this segment, we will focus on systems design, emphasizing logical requirements. The design phase follows the analysis phase exactly in the SDLC methodology. Now, analysts choose the solution that's most realistic and offers the highest payoff for that organization. So when they're looking at the logical requirements, they have to pay attention to some of the things that are realistic for the organization and some of the things that could be conducted or even completed within a relatively short period of time. The output of this phase is really a document with exact specifications for implementing your system. The document will include the files and the databases, the forms and reports, documentation procedures, hardware and software requirements, your computer networking components, and the overall general system specifications. Recall this methodology? It takes you through the whole process, and you can actually see where the design fits in the whole methodology. If you look at this closely, you'll see that design is actually phase 3 of your design of the SDLC methodology. The design includes a logical design, and this is a conceptual detail of your workflow and the interfaces that includes the data and the processes. The physical design includes the hardware platform and even some of the physical components that are required for you to be able to build your system. During the physical design is when you have to ask questions like, should we buy an in-house server? Or should we host our design somewhere else, like in the cloud, for example, in which case you don't actually have control over the physical data that you're storing in your system, but you actually have control only over what you're calling conceptually through, say, a web-based environment. So a good human-computer interface provides that unifying structure for finding, viewing, and invoking the different components of your system. And that includes calling data and processes from that system. And you could be doing that in an environment where you have complete control, or in a web-based environment because somebody else is hosting your data or your application. Now, at this point, it's important that you focus on how information is going to be provided and also how users are going to capture that information and use it in the entire system. So when you structure your data entry, consider the following. Consider entry requirements. Consider the defaults. What sort of values will the system actually show as part of the default? What are the units that you're going to use to be able to pull information out of your system? What are replacement characters going to look like? What sort of captions are you going to look at? In what format, for example? And how do you justify data entries within the system so that you have a consistent format all through? And ensure that your system has a help facility just in case people get lost every now and then. Logical design is your physical requirements design. Now, this component actually works closely with your logical design. So, as part of that design is the systems design with emphasis on physical requirements, and that's what this segment really touches on. The physical design, the results of your logical data design require that you make some key decisions. For example, you have to choose storage format for every attribute in that logical database model. You have to be able to group your attributes from the logical database into physical records. You need to be able to arrange related records in secondary memory, so your hard disk, your magnetic tapes, and be able to make sure that you can store, retrieve, and update them rapidly. Selecting media and structures for storing data to make access even more efficient and effective are key components of your physical design. Again, as a reminder, we talked about this methodology right from the beginning of this course. So this again is your SDLC methodology. The physical design and the logical design are part of phase 3 in the design of your SDLC methodology. So another important decision to make is, will you be storing your data in-house or using a cloud host service? Do you have a server on site? And how will you protect your data? Because security is often a key component of your new design or your new system. So you have to have backup procedures in place. And all of these will touch not only on your financial capability, but also on the resources that you have in-house in terms of people with knowledge of how to manage and operate your new system. Assignments that you're going to be working on in this course is documenting all of the things that you will have put together right from week 2. And that includes documenting your research, documenting the results of your planning and your strategy, document the results of your analysis, and also your design, including physical and logical design. All of those will be documented in a big document that you will have to provide at the end of this course. And that's your business and technical requirements document. So in this particular segment, we're going to look at some of the components of that big document. And one big part of that is the general information. This is the initial part of your document. So in the general information, you will provide and present all the information that is required to plan and design your new information system. In this example, we looked at the electronic health record system as one that you're actually developing. You will narrow down to a component of an EHR. So your general information section should actually provide information on the background to that EHR system. Most of the information in this document should have been identified and possibly created throughout the course. So you get a chance to actually pull everything together. Mind you, this is the document you're going to provide the developer to be able to build your new system. So this document includes the purpose of the project. That's the design of your new HR system, saying that you want a system that will help you better capture patient information throughout the patient life cycle. This is just an example of the purpose that you will be putting together in this document. So the document will also include references, some acronyms and abbreviations that you will use throughout, and even the points of contact. A good example is that you're going to be using EHR all through. But what does that actually mean? So we know EHR means electronic health record. So all of these information will be provided upfront so that the reader understands some of the things that you place in the document and understands the context as well. Into the general information section of your business and technical requirements document, your BTR, you also need to document the current system summary. In some cases, there's a system that's already in place. In other cases, you're building a brand new system from scratch. So let's assume that you have an existing system while you're building something that will be an enhancement over that system. It's still important that you document everything related to that current system. So this second part of your BTR document, really it's about documenting your current system. So the current system summary will include the background as well. What's the project background? This is a summary of the entire application that you're designing. In this case, you're designing an EHR system. So what are the components of the existing EHR system? This is very important because at the end of the day, we want to do a gap analysis that shows us the difference between the current system and perhaps any future system that you're going to be designing. We also want to see the objectives and the current functionality of the existing system. It's totally fine to have an itemized list of the objectives and the expected functionalities for this current system. We also want to see a documentation on the current methods and procedures, current equipment, input and output processes for the existing system, and any deficiencies that we need to address have to be noted as part of the current system summary in your BTR document. We have talked about the general information section of your BTR document. We have also looked at the current system summary for your existing system. The other key component of your BTR is the proposed system. You're building an enhancement over an existing system. In this case, we're assuming that you're not building a brand new system. So in this week, we want to focus on the proposed system and capturing that data as part of your BTR document. So the proposed system will include a summary of improvements. You don't build a system just for the sake of it. There's got to be something that you want to see in terms of the functionality, in terms of how you're going to be improving the existing capabilities and the timelines. We want to document all those improvements as part of the proposed system, part of your BTR document. We also want to see a summary of the impacts of the proposed system on the users of the system, the organizational users, and the operations. Any assumptions and constraints or limitations that might actually impact the new system have to be documented and noted in this part of your BTR document. We want to see detailed characteristics of the new system. All of these workflows that we talked about, we want to capture them in this section. So details of functional and proposed system functions, including potential factors that may hinder project success, have to be duly noted as part of this section of your document. We want flowcharts that are depicting the system and functional descriptions, and we want to make sure that the inputs, the process, and the output components are captured within your proposed system in the BTR document.